All right, so I'm going to go through this as a video lesson. So I'm going to go a little faster because normally in class I would give pause time for writing and just to let everybody kind of go through. You can always pause the video if you need a little extra time to write down the notes. So just make sure to write down all of the notes that I'm giving you so that you can get credit for being in class this week. Just how we're going to do attendance unless you come and attend one of my other classes. All right, so we are on LP7, days 1 through 5, and we are starting chapter 11. So as always, just make sure that you are paying attention to the class expectations, logging into Alex, and working on homework assignments. Even if we were in class this week and we didn't have to deal with the snowstorm, we would only have done a couple of problems together in class because this week is a little bit heavier on the notes. We need to kind of slow down and take some notes on some of the concepts here instead of focusing so much on just getting some homework done. So we only got a couple of problems done on the Tuesday morning class that we were able to attend. So make sure you're logging into Alex, working on your homework, topics, tests, and quizzes. Yes, we have things in all categories open now. Some of the homework has now closed. I believe the very first test is now closed. Remember, things can be reopened. Extensions are available, but you have to ask me for them because of the way I'm grading. I'm keeping a lot closer track of what problems we're doing together in class, what problems you're doing at home, things like that. So I need the ability to kind of control that. So just make sure you're logging in and working on your homework, and I will update it every Monday and send out a new progress report. Make sure you're using your resources here. You guys have a ton of resources. A lot of things available to you. In-center tutoring is a little bit questionable right now only because it's full. Miss Anna is very awesome and she's working very, very hard to help as many students as she can, but she does have limited spaces. So that may not be available to everyone. I do have 30 minutes before and after almost every single class where I can help you. Answer specific questions. That's not really meant for, all-out tutoring for those times. It's more, I got stuck on this question or I got stuck on that question, and you have a very specific thing to ask me. Okay, so make sure you're independently studying, you're trying things on your own. I do have videos for all of your homework. Yes, I did all of that homework. Remember my little smarty comment here. So make sure you're watching those videos. That is a very big resource for you. The other one, you can ask me questions directly from Alex. Alex has examples and explanations, which they're slightly different for those two things, but that's another big resource. Is just Alex alone has a lot of resources. Fev tutoring, which we also have this little color wheel here down, or this little color diagram. That's that 24-hour, 7-day-a-week online free tutoring for grades 3 through 12. You go through clever.com and you'll see this FEV or Fev tutoring down at the bottom. And you can go in and ask questions. There's someone there to help you all the time. So again, a lot of resources that you can use. So make sure that you're using them. All right, let's go ahead and get started here. So this is where you're going to need a lined paper. There was a paper on the notes page that kind of covered some of these concepts, but I like this way better because it actually helps you remember all of these concepts a little bit more if you actually draw them. So on the lined paper, I want you to write example and definition, just as shown. So on the top left, you write example. On the top right, you write definition. So once you have that down, then we're going to draw two lines that are parallel to each other. And remember, the lines on lined paper are already parallel. We can use these lines to our advantage when we're drawing. We are going to use this paper multiple times as far as a couple of diagrams. We're going to draw 3 different diagrams. So don't make the diagrams too big because they won't, fit all on one page. You can use more than one page if you need to. Just, try not to make them huge because then things are a little too spread out. All right, so here are my 2 lines, and I'm using different colors. I suggest you do that as well because it'll help you distinguish the parts faster, and visually it makes a little bit more sense if you're always using, like, say, blue or your pencil for the parallel lines. And then when we draw the next type of line, if it's always a different color, it just visually, it helps you distinguish it very quickly. So it's very good idea. Use different colors if you can. it clicked on there. Sorry. Okay. So now that we have our parallel lines drawn, and leave some space in between here. So I gave myself about 3 lines. You can give yourself a little bit more room if you need to. We are going to write some words in between. So we're going to write words above, below, and in between. So you want to give yourself some spacing there. So make sure that you don't, kind of squeeze it all together. You want to make sure you have space to do the labeling and the notes that you need to do. All right, so now we're going to write the definition, or write the words parallel lines in between. So we're identifying these parallel lines again. Whatever color you use to draw the parallel lines, use that same color to write the words parallel lines. I would suggest not using colors that are difficult to see, like yellow, because you want to be able to see it very quickly. And if you're using very light colors, you're not going to be able to read the words as nicely. So just, be aware of the colors you're using. All right, so now we're going to add the definition of parallel lines. So lines that will never cross and are always the same distance apart. Again, use the same color here so that you know that this definition belongs to parallel lines. You can also write the words parallel lines above here, just to kind of make that a little clearer. But if you're using the same colors, it's all color-coded. It belongs together. All right. So again, if you need to pause, you can. I'm just going to keep moving here just so that the video is not too terribly long. So we're going to draw a transversal, just like you see here, and a line that crosses the 2 parallel lines. Lines don't have to be parallel, although for this example, what we're doing, they are parallel. We're just making them parallel. But a transversal doesn't have to cross parallel lines. It just has to cross 2 or more lines. So here we're going to label transversal. Again, you see how I'm using pink for the transversal, and I have the word transversal in pink, and it's darn near touching the line there. I'm not just putting it somewhere crazy on the paper. It's right here. It's labeling this line. This line is called a transversal. So make sure you're putting it somewhere near the line. And again, do the color coding so that you know they belong together. So now we're going to put the definition here of transversal. And you can see I put parallel lines on this one. So I kind of corrected my oops there without the parallel lines on the last one. So a transversal is a line that crosses 2 or more lines in the same plane. So there's both on the same piece of paper. We can picture a plane as this piece of paper. So both the parallel lines on the paper and this pink line, this transversal, is crossing both of them. So that's the basic definition there. All right, so this diagram is actually what we're going to draw a couple of times because we have some properties that go along with parallel lines and transversals. Okay, so we just need to know what these 2 things were. We need to kind of go back and review these to make sure we remembered them. Because I know they've come up before in math, but it's probably been a while. So we're going to kind of redraw this again, but before we draw that, what we're going to write is alternate exterior angles, just like this. And then underneath it, draw 2 parallel lines and a transversal, just like you did on the last ones. And the transversal doesn't actually have to go in the same direction. Once you choose your direction for yours, try to make it the same so that your diagrams look very similar, because we're going to kind of do some comparisons at the end here. So if you kind of switched your line direction, that's fine. I think, let's see. I wasn't sure if I could write. Oh, no, I can't. It's just a laser pointer. Darn it. All right, I'm going to turn that off. Okay, so you can see what I've done here. I'm going to go back because it clicked on it too many times. So we have our alternate exterior angles and our 2 parallel lines and our transversal. And hopefully we understand we're identifying angles. And there are a lot of angles. There's this guy here, so this section. We also can look at the other side here that's created. So remember, an angle is created by 2 rays that have a common vertex or common endpoint, right? So there is a whole lot of angles created by these 2 parallel lines and this transversal. All of these areas are angles. Alternate interior, we want to go through and define these words. So what I'm going to have you do is shade, I say highlighter or color pencil or crayon. You could do this with a regular pencil if you just did it different directions for exterior, and then we're going to do interior later. So you could just kind of do hashing or hatching or cross-hatching if you've taken art class, or drawing. Just different ways of shading so that you can identify the different areas. So I'm just using some blue here. Excuse me. So here's exterior / outside. Yes, I want to see both the words exterior and outside on both the top and the bottom. This is a way of identifying both of these areas and relating the words exterior and outside so that we remember that. And it's not necessarily about understanding right this second that exterior means outside. It's about remembering it later. So you may know that right this minute, but I want you to remember it in a couple hours, a couple of days, in a couple of weeks. You can come back to these notes and look at them and see that you put exterior and outside together. Okay, so just make sure that both those words are present on both top and bottom. So it should look just like this, or something like this. It doesn't have to be exactly the same colors, but it should be something very, very similar to this. You don't necessarily have to make a rectangle either. You can just kind of shade the area. So the system just gave me a rectangle when I did that. All right, so now we're going to draw a double-sided arrow as shown below and label it alternate/different sides because we're dealing with the word alternate. So alternate means different. And in this case, when we're talking about parallel lines and transversals, it means different sides of the transversal. So it means different sides of the line, and specifically the line is the transversal. So I want you to do this, and I did it in the same color as the transversal so that we know that this is relating to the transversal. I'm actually talking about that line, that pink line. So alternate exterior, exterior means outside of the parallel lines, this area outside either on top or the bottom. And then alternate meaning either on the left or the right. Okay. All right, so now that we've dealt with alternate and exterior, those two words, we can start to identify some angles. So we're going to show alternate, the exterior angles in this diagram. So again, we can use different colors, so pick two brand new colors. I'm going to use kind of a mint green and an orange if you want to match mine. That's perfectly fine, but you do not have to match mine. Just make sure they're different colors. You want them to be very obviously different. So I know I had some students in class that were using colors that were very close, like a dark red and a brown, or two greens. We want them to be different colors so they're easily identifiable. So here's our first ones. I have my mint green here and my mint green here. So they're both outside. They're both exterior because they're both in that shaded blue area. And this guy is on the left of the transversal. Remember, my pink line is my transversal, so it's on the left. And this guy's on the right of the transversal. And they're both outside or exterior. So this is what we call alternate, different sides of the line, exterior, because they're both outside, and they're both angles. So alternate exterior angles. We have another pair here because I have this section and then the section down here. Again, they're both exterior. They're both in that blue section still. And now I'm starting on the right side and I'm going over here to the left side. So we just want to make sure that we understand that this is where they fit. So we have two properties. Oh, why is it going backwards? What is it doing? Sorry, my presentation's being silly here. So we're going to go forward. We have two properties or two theorems that go with this. So the first one, if two parallel lines are crossed by a transversal. So this is if we're starting with parallel lines and a transversal. Then alternate exterior angles are congruent. So if we start with parallel lines and a transversal, then we can go and prove that these alternate exterior angles are congruent because they have to be if we have parallel lines and transversal. We can also do the converse or the opposite of this. It's not fully the opposite, but we're starting with the angles instead of the parallel lines. So now it says if two lines are crossed by a transversal, so we don't know they're parallel yet, it's just two lines, and alternate exterior angles are congruent, so we're starting with those alternate exterior angles being congruent, then the lines are parallel. So these are the kinds of things that we're going to use in proofs, which we've kind of touched on a little bit here and there in class. We're going to start doing those a little bit more as we move forward. And the way that you complete a proof is that you make a statement, say, this orange angle is congruent to this orange angle. Well, how do you know that? Oh, I know that because of this theorem here. Alternate exterior angles are congruent. Or the blue line is parallel to the blue line because I was given that the orange angle is congruent to the orange angle. Well, how do you know that? Because of the converse of alternate exterior angles are congruent. And that's what we can refer to these a little easier. Instead of saying all of the words, we can say alternate exterior angles are congruent. I tend to shorten it like that. Or the converse, meaning the opposite of alternate exterior angles are congruent. So that means I'm starting with the angles being congruent and I'm moving to parallel lines. So it all just kind of depends on what we're starting with. Okay, so now that we've kind of gotten through all these pieces, I want to show you a live demonstration of what this looks like. So, oops, lots of stuff going on in the background there. Okay, so if I scroll down to this one, and this is called mathisfun.com. This website has a whole bunch of different kind of just math concepts that you can go through, and a lot of them are interactive where you can actually kind of change things and see how it works. So I can click up here and go alternate exterior angles, and it'll actually show you, this is A and H, or B and G. And if I click on this guy down here, I can actually move the angles around a little bit. So now it's showing you the actual angle measures. So we can see that they're congruent, 112, 112, 68, 68. So I can see that. And if I move these around, I, in fact, keep them congruent. They just change the sizes, but it's still 102, 102, 78, 78. So they're still congruent to each other. This is true because the lines are parallel. If I click this button parallel, it actually means that they're not going to be parallel anymore. When I drag, only one will move. And if you notice now what happens, they're still showing me these alternate exterior angles. We still call them that, but they're no longer congruent if the lines aren't parallel. So remember, that was part of that theorem. If two parallel lines are crossed by transversal, then alternate interior angles are congruent. We can still call them alternate interior angles, exterior angles, but we don't, the congruency part goes away if they're not parallel. So if I click parallel again, now it'll fix it. Now I have them congruent again because my two lines are parallel. So just make sure that you understand that concept. They have to be parallel to be congruent. The naming is the same though. Whether they're parallel or not parallel, we still call them alternate exterior angles because they're on the outside of the lines and they're on alternate sides of the transversal. So we still call them alternate exterior angles. All right, so let's go back to our presentation here. So now we're going to look at alternate interior angles. So I want you to do the same thing. We're going to write alternate interior angles, and we're going to draw that same diagram we just drew. So just move down on your paper, give yourself enough room, and again, use the coloring that you've already done. So I have my parallel lines in blue, I have my transversal in pink every time. So it's very identifiable to me that those were my parallel lines, and the pink line is my transversal on each and every one of these diagrams. I don't have to worry about trying to remember that later because it's already identified for me. All right, so now what we're going to do, same thing we did with the exterior angles, we're going to deal with the word interior and again with the word alternate. So interior, and you can use a highlighter, colored pencils, crayons. Again, you can use your pencil, just if you did like shading, shade in a different direction for the interior so that you can kind of see the difference very quickly. So interior means inside. So now we're going to shade in between the parallel lines, inside. And I want you to shade, again, you don't have to make a rectangle, just shade the area. And I want you to write the words interior / inside. Yes, put both words. I want you to relate interior with inside. So make sure you write both words. So it should look just like this. All right, so now we're going to draw that double-sided arrow again, just like we did before, to show the word alternate. So alternate still means exactly the same thing as it did in alternate exterior angles. It still means different, or alternate means different sides of the transversal. I said or, but there's only really one word there. So it's the same idea on both of these. When you hear that word alternate, when we're dealing with this concept, it means different sides of that line. All right, so now we're going to show the interior angles in this diagram. And again, we're going to use the same two colors that we used on the exterior angles, but this time what I want to do is make sure that the going across the vertex here are the same colors. So if you remember, I had green on the top. I had green on the top, and and orange, or not on the top, on the left, and orange on the right. So if I go across the vertex, I want that to be green so that they kind of match. And we're going to bring these together and I'm going to show you what I mean. So if you don't necessarily use the same colors, it's okay because you can't really bring them together on your page. Not the way I'm going to do it on the presentation. But we want those to kind of be matching, and there's a reason for that. There's a relationship there. So we have both of these guys on the inside. They're both in the yellow area here that I shaded. One is on the right, one is on the left of the transversal. So they're on alternate sides of the transversal, and they're both interior. We also have this section and this section. So again, I have orange and orange, and I had this little section as orange on the exterior version of these notes. So I matched them up on purpose. So here are our two interior angle, alternate interior angle pairs. So there were two alternate exterior pairs. There's two alternate interior pairs. Okay. So we have those same two theorems that go with alternate interior angles. So if two parallel lines are crossed by a transversal, then alternate interior angles are congruent. Exact same wording. Yes, rewrite it because this is part of the notes. So it's exact same wording. The only difference is you change interior to exterior. That is the only thing we're changing in these wordings. But it is a different theorem. It's its own theorem, just the same wording. But now we're dealing with interior angles. So again, this one is starting with parallel lines crossed by a transversal. So I know the angles are congruent. I can prove them congruent. The second one, if two lines are crossed by a transversal and alternate interior angles are congruent, then the lines are parallel. So in this one, I have just two random lines with a transversal going through them, and the angles are starting congruent. I already know that. I'm given that. And I can prove that the lines are parallel. So it's the same wording. We're just changing we're changing exterior to interior. Okay? So these are our two big concepts. We're going to look at a couple more here, but these are the two big ones. So I'm going to go ahead and, go back to that live example here real quick. So if I go back down to this guy, and I'm going to go to alternate interior angles. So now you can see it's kind of flipping back and forth, and they are congruent. 68, 68, 112, 112. I can move this around. So I have 104, 104, 76, 76. So they are congruent to each other. I can see that. If I unclick parallel, same thing will happen that happened to the exterior angles. If I drag one away and it's no longer parallel to that other one, we still call them alternate interior angles, but they are not congruent anymore. So the 76 and 84, 104 and 96, definitely not congruent anymore. They're still alternate sides of the line of that transversal, and they are on the inside or in between the other two lines, so we still call them alternate interior angles. If I re-click the parallel lines, now we have that congruency property, meaning that they're the same again. Okay, so let's go back to our presentation. And again, I know I'm going through this a little fast. You can pause as you need to, but it's a little bit easier, kind of just keep going through this as I don't have, students live to kind of ask me questions and check on here. Okay, so we're going to take a look at both of those diagrams that we just drew. I know you don't have it on your papers like this because, you have probably the exterior angles on top and the interior angles down below. So I have them kind of next to each other so I can see. So we want to see what do we notice about these two. So when I bring them together like this, and I know they didn't quite come together perfectly here, the angle should have been up a little higher. But with these guys, what I want you to notice is we have the green and the green, and I made this arc a little bigger than this guy, so they don't match up perfectly. But what we call these are vertical angles when I go across the vertex like this. And vertical angles are always congruent. So we have green to green, orange to orange. So that's why I wanted those colors to match up so that we could see that relationship really quickly. This has nothing to do with parallel lines. It doesn't require parallel lines. It only requires two lines crossing each other. That's it. So it happens anytime we have like basically an X. Anytime we cross two lines, we have vertical lines because we can go across that vertex, that point where they cross. Okay, so this is one of the big ones. We use this one all the time. Yes, make sure you are writing this in your notes. You don't necessarily need to redraw this diagram like this. I did have some students in class that were redrawing it. That's fine. But these are just the two diagrams you drew up above on your notes, just kind of combined together so we can see them. The main thing here is that I want you to start writing out some extra properties we have from this. So the other one we have here is angles on the same side of the transversal. So again, transversal is my pink line here. So if I focus on the left side here, so I'm going to look at the left side. So they're both on the left side, same side, but one is outside and one is inside. And these are congruent. So here I have exterior for this green and interior for this green. So they're both on the left side of the transversal, but one is exterior, one is interior. Or I could do the same thing with the oranges here. This orange is interior, and if I go down here, this orange is exterior, but they're both on the left side. So whenever this happens, they are congruent as long as the lines are parallel. Again, that's the big requirement. The lines have to be parallel for this congruency to work. We can do the same thing on the right side as well. And we call these corresponding angles. And the big thing that you can describe with these ones is they're in the same relative position. And what that means is if I look at this green one here, it's on the left of the transversal and it's above its parallel line. If I look at this other one, it's to the left of its transversal and it's above its parallel line. I can describe them in the same way. Above the line, to the left of the transversal. And again, they don't necessarily have to be parallel lines in order to call them corresponding angles. We still call them that whether or not it's parallel. But in order to be congruent, the lines have to be parallel. Okay, so let's take a look at that on the diagram there, because I like my little live diagram here. It's a very neat little thing here. So if I click on corresponding angles, we have a lot more options on corresponding angles. So if you notice, we have 112, 112, 68, 68. These are also 68s, and these were also 112s. So there's a lot, and I can click on all angles so it stops bouncing around here. But it was 112 and 112. So left and on top of the parallel line. Left of the transversal on top of the parallel line. And then we have 68. That's to the right of the transversal, but it's also on top of the parallel line. To the right of the transversal on top of the parallel line. So this 68 and this 68. And you can see the vertical angle is also matching because we have 68 and 68 across the vertex. 112 and 112 across the vertex. Right? So there's a lot of matching going on here, a lot of congruency. Again, if I unclick parallel lines, this is going to change. Now they're no longer congruent from the top section to the bottom section. If you notice, it didn't change the vertical angles here, though. Still 68, 68, 112, 112. Down here, they're not the same numbers as the top, but they are congruent for the vertical angles. Remember, that doesn't require parallel lines. That's just two lines crossing each other. That's when that happens. But now if we notice the corresponding angles don't match up, they're not congruent anymore. We have 112 here for this to the left and top, but left and top of this line is 95, not 112. So they're not congruent anymore. We still call them corresponding angles. They're still in the same relative position, but in order to be congruent, these have to be parallel. Now they're congruent again. I have 95 and 95. 85 for the bottom and left. 85 for the bottom and left. Okay, so it's all in the way you describe where is it. All right, so if we go back, we have, I think, one more property, and then we're actually going to look at some problems here. So angles on the same side of the transversal. So that's the same way we started out the last statement. But now they're either both inside or outside. So now I would look at, if I'm looking at this green one, and I want them to both be on the same side, so I'm looking at the left side again, but I want them to both be either outside or inside. Well, this one's outside, it's exterior, so I'm going to go down to the bottom here and see that it's an orange one. So I have green to orange. If I look inside, and I start on this orange one, and I want to stay inside and look at the same side, I'd have green. Well, these aren't congruent, but they are supplementary, which means they add up to 180 degrees. And the reason for that is if we're looking at a line, these two are on a line, if we look at this green and this orange, well, any two angles on a line add up to 180 degrees. They have to. That's how much a line adds up to. So if I know that this orange is congruent to this orange, then green plus orange equals 180. Well, green plus orange still equals 180, even though I'm going down to the bottom. It's still the same angle, it's just moved down because orange and orange are corresponding angles. Green and green are corresponding angles. So it's just a kind of practice in moving those angles around a little bit and relating them. You can do the same thing on the inside and on the outside. So we call these same side, because they're on the same side, either interior or exterior angles. If they're both interior, we'll call them interior. If they're both exterior, we'll call them exterior. Okay. I've also heard these called consecutive interior angles or consecutive interior angles. And consecutive simply means that they one right after the other. Kind of an idea. So if I'm looking at consecutive exterior angles, I'd have exterior and then I'd go to the next exterior angle, which would be all the way on the other side. So consecutive can be a little bit confusing to me because it's not truly one right after the other, which I would kind of go one and then the next one. So I do kind of like this idea better of the same side. Just depends on the program you're using, or, you know, if you're looking in the book, or if you're using Alex, or if you're looking it up online. They all sometimes use a little bit different wording. Okay, so, I didn't show that one on the mathisfun.com. It's a little harder to see with the angles jumping around, because if I clicked on same side exterior angles, it would kind of jump around to go, you know, top and bottom, or in the middle here, this guy to this guy. You'd have to very quickly be able to add those to see the 180 degree relationship. So it's not as easy to visually see, but you can definitely go to mathisfun.com and kind of try it out. In fact, I'd have to exit out of this in order to see it. So I'll just keep moving here. So we're going to actually look at practice problem number 1, and this would be on your notes page. So because you probably don't have your notes page, what I'll have you do is just draw this on the paper. And if you've run out of space, you can go on the back side. You can go on a new piece of paper, however you need to do that. So make sure you draw this diagram, label M, N, B, and put the numbers here, 1, 2, 3, 4, 5, 6, 7, 8. So make sure you draw this diagram, because filling out this notes page and just stating the corresponding angles, if we just pick 2, well, that's great. But if we don't have a diagram to match it up to, it doesn't mean anything. We need to have that diagram so that we know what were we grabbing these angles from, and I can go back and look at them again. So draw this guy out, and then we're going to take a look at these questions here. So if you need to, pause it real quick and draw that. But I'm going to keep moving here. So we're going to identify alternate interior, alternate exterior, and corresponding angles. So they want one of each. Well, remember, there's more than one pair of each of these. So corresponding angles, that one actually has the most pairs, right? So if I go to my diagram here, and I'm labeling this guy, here's my transversal. That's the first thing I suggest that you do. Label the transversal. Find it first. Identify it. And the easiest way to identify it is, remember, it needs to cross 2 or more lines in order to be called the transversal. So if I'm going through and I'm looking at M here, does M cross 2 or more lines? No, it only crosses 1. How about N? Nope, N only crosses 1. But this one here, B, well, it crosses N and M. That's 2 or more lines, right? It's at least 2. So this is my transversal. So that's your first task. Label the transversal so that you know, okay, this is my alternate sides when I'm talking about the word alternate. And the other 2 lines are your, in this case, they're not parallel because we can kind of see that they'd be coming together, but they're your other 2 lines. Okay, sometimes they're sideways like this, sometimes they're standing up. So sometimes this entire thing is kind of shifted, kind of turned the other way. So the transversal is going from side to side, and the parallel lines are going top to bottom. We still have inside, we still have outside, and we still have 2 different sides of the transversal. Doesn't matter how we turn this diagram around. Okay, so if we start looking at corresponding angles now, I can have 2 and 6. So again, 2 is to the right of the transversal and it's above the line. 6 is to the right of the transversal and it's above its line. Same relative position. So I can do the same thing with a bunch of these other guys here. So I'll let them all fill in. You can see lots of different colors. And I like the different colors because it's very easy to identify now. If you do this all with a pencil, it's not going to mean anything because you're not going to be able to tell the difference between the angles. So make sure you're using different colors so that it's easy to identify. Okay. So we can see 4 and 8 because it's on the bottom of the line to the right of the transversal, on the bottom of the line to the right of the transversal. Orange and orange, so 1 and 5, they're both to the left of the transversal and above their lines. 3 and 7, they're also to the left of their transversal and they're both below their lines. Right? So I can describe them in the same way. So I picked 2 and 6 here, but I could have picked any one of those pairs. So any one of these is the correct answer. You can also, because this is 4 different answers here, but the order how I list them doesn't matter either. So I could have 6 and then 2, or 5 and then 1, 7 and then 3. Okay, so there's actually 8 different possible answers here, just depending how you type it in. But you can't mix them together. I couldn't change this and say, oh, that's weird. That changed to 2. That should stay 1. Didn't even notice that mistake earlier. Darn it. I'll have to fix that. So why does it keep doing it? All right. So I can't mix the 2. I can't say, like, what that says, that's an oops. It can't say 2 and 5. Well, 2 and 5 are not corresponding angles, right? They're on alternate sides of the line. And remember, corresponding angles are on the same side of that transversal. So this wouldn't work, right? So that's definitely an oops. It should be 1 and 5. All right. So we're looking at alternate interior angles for the part B here. So now we want to go in between, inside the lines, and we want them to be on alternate sides. So if my transversal is going somewhat up and down here, I have a left and a right. So if I look at the first one here, 3, that's on the left, 6 is on the right. And they're both inside. The other 2 lines are in between, right? Or I could look at 4 and 5 because 4 is on the right, 5 is on the left. Again, they're both inside, they're interior. Either one of those is correct. I picked 3 and 6, but you could very well put 4 and 5. It would still be correct. All right. The last one here is alternate exterior angles. So if I'm looking at alternate exterior angles and I look at number 1, here this one's exterior, 8 is exterior, and I have the left and I have the right. So I have the alternate with left and right, and I have them both in exterior. Or I could look at 2 and 7. So again, they're both exterior. 1 is on the right, 1 is on the left. So we just want to make sure we're kind of meeting both of those needs there. So I went ahead and picked 1 and 8, but you could have also picked 2 and 7. All right, so that's kind of the first basics. Now we're going to get into looking at angles with this. So now they're actually going to give us some information and ask us to solve some pieces or find some pieces. So we have 2 parallel lines are cut by a transversal as shown. So we already know they're parallel lines. So those congruency properties that we were looking at before work. They are parallel lines. And then they tell us that angle 6 equals 107. So we want to label our figure and use those angle properties. We just learned to fill in some blanks here, so find the missing angles. So let's go ahead and label our transversal. So here's my transversal. Where's my word transversal? That should be popping up. I bet you it'll pop up in a second here. So here's my 107, right? Because they told me it's 107 for angle 6. And then they said find angle 1 and 3. So we want to figure out how can I bring this 107 up to the area where 1 and 3 are, because this is down in the bottom half. Well, I want it to be up in the top half, don't I? I want to bring it up there. So there's a couple of different ways we can do that. You kind of saw me click a little quickly there. We can use corresponding angles. 6 and 2 are corresponding, which means they are congruent. So now I know that 2 equals 107. I could have also used alternate interior angles and used 6 and 4. That would have brought 107 over here. I could also use same side interior angles and deal with 3 and 6. These two have to add up to 180 degrees. Remember, it's one of the very last ones we just practiced there, where we looked at that property. So if they're on the same side of the transversal and they're both inside, they add up to 180 degrees. So I went ahead and went with corresponding angles in this one, but tons of different pathways. It just kind of depends on which one you see. So now, what do we know about angles on a straight line? What do they have to add up to? Well, anytime we have a line with angles on it, they have to add up to 180 degrees. Okay, so now I know I can add angle 1 and 2, and that's going to give me 180 degrees. So you can see I have my orange one, my red 2, because I used that color coding here, and I know that angle 2 equals 107 because it's corresponding angle with angle 6. So now I can solve for angle 1 by simply subtracting. If I know they have to add up to 180 and I'm using 107, well, I'm going to subtract the 107 to see what's left over. I want to know what is left over for my angle 1, so it's 73 degrees. All right, so now we're going to look at angle 3 because we also need to answer that. Okay, so angle 3, some of this is re-highlighting a little bit. So remember, we have 1 and 3. So we could use 180 degrees again because 2 and 3 are on the same line. So I could do that math again and subtract 107 from 180. And I'd end up with the exact same thing that I ended up with on the last one because it would be the same calculation here, wouldn't it? I would just change, instead of 1 plus 2 equals 180, I'd have 2 plus 3 equals 180. But 2 is still 107, so I'd still subtract 107. So we're going to have the same angle here because they're vertical angles. So that's the route I went when I was looking at this diagram. I said vertical angles are congruent. 1 and 3 are vertical. They're across the vertex. So if 1 is 73 degrees, then 3 is also 73 degrees. Oops, clicked too quickly there. So this is just the idea of applying some of the properties. Okay. Now we're going to apply the property algebraically. Okay. So they're not just going to flat give us the degrees and say move it around. Now they're giving us little expressions here. And we have to fill in. We have to find the measurements or the value for x and z. So these two, if I looked at these two, they'd have to add up to 180 degrees, right? They're on a line together. But we don't want to write that quite yet because I'd have x and z in the same equation, and I can't solve it when there's two variables. So we want to focus and either bring 60 up to z or 60 up to 4x minus 28. We want to bring these together somehow so that we have one variable and 60. So we're going to look at 4x plus or minus 28 and 60 and think about how are they related. Well, if I'm looking at my transversal, I forgot to highlight the transversal on this guy. So this is the transversal here, right? This is the one crossing the two lines. Well, 60 is outside, 4x minus 28 is outside. 60 is on the right, 4x minus 28 is on the left. So this is alternate in exterior angles. And we know that alternate exterior angles are congruent if the lines are parallel, which they told us the lines are parallel. Okay, so now we can write a little equation to bring these together. 4x minus 28 has to equal 60 degrees because they're alternate exterior angles and we know they are congruent. So now we just go through and we start solving this. So just like we would normally do, we look at what's being added or subtracted on the same side as the variable and do the opposite. I'm going to add 28 to both sides And 4x drops down, negative 28 plus 28 cancels. 60 plus 28 is 88. So now I'm multiplying by 4. Well, I don't want to know what 4x is. I want to know what just x is. So I'm going to divide by 4 on both sides. 4 divided by 4 cancels, and I just have x. 88 divided by 4 is 22. So now we know what x is. That was one of the answers. Now we need to know what is z. So there's a couple of different ways we can do this. So if we're trying to relate 4x minus 28 and z, which I kind of already talked about at the beginning there, they are straight angles. And straight angles, or angles on a straight line, are supplementary, meaning they add up to 180 degrees. A big thing to remember here, 4x minus 28 is 60. We already know what it equals. If you took x, which is 22, and plugged it in here, 4 times x is 22, or 88, sorry, I'm multiplying funny. 4 times 22 is 88, minus 28, 88 minus 28 is, dun dun dun, 60 degrees. So I already know this angle equals 60. I don't actually need to use 4x minus 28. I can use 60. So this is what it would look like if I was plugging it into 4x minus 28. But remember, we need to replace that with what it actually equals. It actually equals 60. So 60 plus z equals 180. Well, now I just need to get z by itself by subtracting that 60 away so I can see what's left over. So z equals 120 degrees. So this is kind of getting into a little bit more of the algebra of it. So we need to use those 4 big pieces that we were learning earlier, actually 5 big pieces, sorry, because we had alternate interior angles, alternate exterior angles, corresponding angles, same side interior angles, or some same side exterior angles. So we had kind of 5 different properties that we can use to move these pieces around on the diagrams to kind of bring them together. So a lot of the time, actually every time that I've seen so far, they're going to give you some information on one section and some other information on another section, and you have to bring them together with one of these types of properties that we learned, or theorems that we learned. Okay. All right. So we're going to move forward to section 3. That was section 1 and 2 kind of mixed together a little bit. Were all of those notes. So I know that took a little while. That was about 45 minutes of notes there, but that was 2 full sections of notes. So now we're going to take a look at section 3, which is about slopes of lines. So we're going to review the slope formula. So remember, and I know you don't have your notes page on this one, so just write out the notes for it. You kind of do the best you can. With this one, you can draw a very simple little diagram for it. It's really not hard to draw a little grid. If you have grid paper, that's great, but you can do this on line paper very easily, just drawing the coordinate and giving yourself some simple little marks. So you can very easily draw this diagram out. Yes, draw the diagram, because without the diagram, a lot of this doesn't mean anything. Okay, we need the diagram. All right, so remember, the slope of a line is the measure of its steepness. How fast is it rising or falling? That's really what we're asking when we say, what is the slope? So we're usually given 2 points, and we label them like this: x1, y1, x2, y2. Remember, the 1 and then the 2 here is just telling us it's from point 1 or point 2. That's all this little dropped down number means. It's part of the name. Okay, so we can use this formula down here, and it kind of already auto-filled a little bit here. We have slope equals rise over run, so it's kind of how we remember it, rise over run. But the way we calculate that when we're given 2 points is we subtract the y coordinates from each other, so y2 minus y1, and then on the bottom for run, we subtract the x coordinates, so x2 minus x1. A big thing is if we're given a graph, we can see rise and run visually. So in this case, we are given a graph. So you can either draw the graph, or if you want to use the points, you can note the points. I'm going to use the graph because it's here. So you can see I can go from this point. I'm going to rise up 6. So I'm showing you rise is positive 6. And then I'd have to run positive 4 to get over to this point. So I'm using 2 straight lines, How do I get from one point to the other? I want to go up or down first, that's my rise, and then I want to go right or left for the bottom, because that's my run. So I have 6 over 4. Don't forget to reduce, because 6 over 4, they can both divide by 2. So we have 6 divided by 2 is 3, 4 divided by 2 is 2. So the slope is actually 3 over 2. So for every 3 that it goes up, 1, 2, 3, 1, 2, 3, it goes over 2, 1, 2. So you can see I land right on that point. And then I can do it again. Darn it. Clicked on the piece here. 1, 2, 3, 1, 2. So I can follow that slope and keep going. I could even keep going 1, 2, 3, 1, 2, and I land on another one here. So I can see those points continue to work. So make sure you reduce it so that Alex will accept it that way. It won't accept it if you don't reduce it, or it's going to remind you to reduce it. Okay. All right, so this is the basic idea of slope. Now we're going to look at it when they only give us points, because that's the second piece they give us for problem number 2. So again, we have the steepness, the measure of its steepness. We're just looking at how quickly is this line rising or falling. So we're using that same formula. We're going to subtract the y's on the top. That's our rise, because that's the difference in the y coordinates. That's how far up or down we're going. And then the run is the difference in the x coordinates. How far right or left are we going? So we're just kind of taking a look at those points. So the first thing I would have you do in class, if we were actually, doing this in classroom, is I would have you label the coordinates, just like this. So write x1, y1 right over 2 and 5. Write x2 and y2 right over 8 and -4. So actually label your coordinates. I know it seems a little tedious at first, writing some of these labels out, but make sure you're writing these down. It makes it so much easier when you go to fill in some of these different formulas. When you're using slope or midpoint or distance formula and you have to refer to multiple points, if they're already labeled, you don't have to worry about it. All I have to do is say, well, if I'm looking for y2, I just come over here, y2, well, that's -4. If I'm looking for y1, okay, well, y1, that's 5. It's already labeled for me. So let's go ahead and start filling this one in. So I just brought the formula, same formula down here. So we're going to start filling this in. So we can see here's y2 and y1. So I have -4 and 5. If you notice there's a minus here, that's part of this equation. So this negative, it's even in a different color there so that you can see it's kind of permanent. It's part of the equation. Okay, now let's look at the x coordinates. So we have x2 and x1. So we have 8 minus 2. If this was a double negative, that happens every once in a while where your first coordinate is a negative, 2 negatives make a positive, so it would actually switch it. That's not happening right now, right? We just have a positive number here. So it's -5, -2. So just make sure you're paying attention to those little rules when you're going through and doing things. So we have -4 minus 5, which is -9. 8 minus 2, which is 6. Don't forget to reduce. 9 and 6 can both divide by 3. So -9 divided by 3 is -3. 6 divided by 3 is 2. All right. So that was the idea of slope on a graph and with just the coordinates. Okay. So kind of the visual concept and the actual algebraic concept here. Again, you're just figuring out how far up and down am I going? Up or down am I going to get from one point to the other? That's your rise. How far right or left am I going? Okay, so that's your run. All right, so now we're going to take a look at finding the slope of a horizontal or vertical line. Remember, horizontal line means that it's flat, right and left. Okay, vertical means straight up and down. So these have kind of some special slopes that we have to deal with. So I like my little stories that I come over here. So when dividing by 0, so we have this, 5 divided by 0. And a lot of students know that it's not allowed, but they don't know why. So we do call this undefined. We're not allowed to do this. Well, let's look at our example. So if we were in class and we will order a pizza for the class, and when it arrives, there are 0 pieces in the box. There's nothing in the box at all when it arrives. But now, when we look at it, there are 5 pieces left. Well, that doesn't make sense, does it? where did the 5 pieces come from? If there were 0 when it got here, where did the 5 pieces come from? Is that magic? No, it doesn't make sense. That's not possible. So we call that undefined. We can't start with 0 pieces like that. Okay? But when 0 is being divided by 0, we have a 0 slope. So this is what it looks like. 0 is divided by another number. Okay? So sorry, 0's I shouldn't have said it that way. That's a little typo also. When 0 is being divided by another number, not 0. Silly me. So in this case, I'm doing 5 again. So now let's look at that pizza example. So we will order pizza for the class again. And when it arrives this time, there are 5 pieces in the box. Now we have 0 pieces left when we look at it. Well, that makes sense, right? What happened to the 5 pieces? Well, we ate them, right? Hopefully that's what happened. Hopefully there was, enough. I only had 5 students in class that day, and there was enough for everybody. But this makes sense. I can have 0 left of the 5 I started with, but I can't have 5 of nothing. It doesn't make any sense. So just make sure you're paying attention to the difference in these two. Okay. So now we're going to apply that to slope here. So we have find the slope of the line passing through these 2 points. They gave us 2 points just like they did on the last one. So let's go ahead and apply this concept here. So we have -6 and 9. That's our y. -6 is y2. 9 is y1. And then we have x2 and x1. So we have 8 and 8 for our x's. So now -6 minus 9 is 15, -15. But on the bottom I have 0. So I have -15 of nothing. Oh, that's not allowed. That doesn't make any sense. I can't have something of nothing. So this is undefined. And now we're going to find the slope of the line passing through the points -4, 9, and 8, 9. So if you notice, there's something repeated in both of these. The 8s are repeated in the first one. No, the 9s are repeated in this one. So they specifically want us to practice these 2 concepts. So we have our equation again here. So now our y's are 9 and 9. So we have 9 minus 9. And our x's are 8 and -4. So here's that double negative I was talking about on that last screen. So I have 9 minus 9. Well, that's 0. 8 minus -4 minus negative, that's actually plus. So that means 8 plus 4, which is 12. Well, this is okay. I can have 0 of 12. It just means there's nothing left over from what I started with. I started with 12 here. That would have given me, if we're talking about a pizza, it had 12 pieces. Okay, so that's how many are in the hole. Well, right now I have 0 of those left. That's okay. That's possible. It just means I have 0 slope. Okay, so just a little different ideas for those 2 pieces. All right, finding the coordinate that yields a given slope. So this one's a little different because we have to use this slope formula in a slightly different way. We're still using it, but now we know the slope, and we're missing one of these pieces here. So we have the points -8 in R and -5 and 11, and they lie on a line with a slope of 2. So I already know what the slope is, and I need to find this missing coordinate to make that true. So we're going to use the slope formula here, and I'm going to do the same thing. I have y2 minus y1, so here's y2, here's y1. I have 11 and R, and then I have -5 and -8 for my x's. So I filled those ones in, and that's going to equal 2, and I put it over 1. Remember, all numbers have a 1 underneath them. So if our slope is 2, that's a rise of 2 and a run of 1. So it's a little bit more helpful to have it in a fraction there so that you can kind of see that it kind of makes a proportion a little bit. So let's simplify this a little bit because we have 11 minus R. Well, I can't simplify that, but I can do -5 minus -8. Remember, this is going to be plus. So let's bring this down here. So -5 plus 8, well, that's 3. Nothing else changed, right? I still have 11 minus R. I still have 2. The only thing that changed here is 3 because I still have 1 on this side. So I just combined these numbers here. So now what we would do is I want to move that 3 out from under. The other thing you can think of is, if you remember this, cross multiplication here. 3 times 2 would equal 11 minus R times 1. So we can also cross multiply to kind of solve this guy. But since this is a 1, I just went ahead and started dealing with this 3 because I want to get this r by itself. So I'm dividing by 3. Now I'm going to multiply by 3 to cancel these out because 3 divided by 3 is 1. So now I just have 11 minus r equals 6. So if you notice, that's the same thing as the cross multiplication that I said out loud. 3 times 2, well, that's 6. 1 times 11 minus r, well, that would be 11 minus r. So we did cross multiply there. I just kind of did it a little differently. I didn't show you that. All right, so now to get r by itself, I want to subtract 11 from both sides. So 11 minus 11 cancels. Remember, there's this negative with the r. We can't just get rid of it. It comes down here. 6 minus 11, that's where I got negative 5. I don't want to know what negative r is, though. I want to know what r is. So whenever you have a variable that's negative at the end, you basically just take that negative and give it to the other side. Okay? You're basically multiplying or dividing by negative 1 when you do that. You're just moving it from one side to the other. So it becomes positive r, and because this was negative and I'm giving it another negative, it becomes positive 5. So in order for this to be true, to have a slope of 2, r has to be 5. All right, so we have one more. I believe this is the last one we're going to look at here. So graphing a line through a given point with a given slope. So we're going to graph the line with a slope of -1, passing through the point 5, 3. So our first task here is, let's plot the point. That's our starting point. So I'm going to go 5, 3. Remember, it's the first number is x, which is right or left. The second number is y, which is our up or down. So I'm going to go 5 to the right because it's positive. 1, 2, 3, 4, 5. And then 3 is also positive, so I'm going to go up 3. And I'm going to put my point right there. Okay, so now I have my point. That's my starting point. From that point, I'm going to use slope to go to another one, to find a second point. Okay, so remember, it's rise and run. If they tell me my slope is -1, that's my rise. On the bottom will be a 1. If it's not a fraction, if it's a whole number, like this, then I put a 1 underneath it so that I can do rise and run. So with this one, if I'm rising -1, that actually means I'm going to drop 1. I'm going to fall. And then I'm going to run 1 like this. So there's my point. And that all kind of animated very quickly there. There we go. So it's 1, 1. And now here's that point. And then the third task is make sure you connect that line when you're doing that. If you don't have graph paper, I know not everybody has graph paper, but you can very easily draw a grid. Try to be neat about it, okay? The neater you are, the nicer, the more it'll make sense when you go back and look at it later. But you can nicely draw a grid. You don't have to have grid paper to do this, okay? All right, so that is the end of that lesson. We didn't go through each and every single problem, but we went through most of them there. So make sure that you finish writing all of those notes. If you need to go back and rewatch any parts of the video, definitely go back and rewatch the video to get credit for attendance for this week. If you're not attending one of the classes, and I know we have a couple cancellations because of the snow, just make sure that you submit your notes here on Google Classroom so that I can go take a look at those later and give you credit for being in class. Because this is kind of the easiest way we can figure to do this for this week. So please let us know if you have any questions, or if you'd like to try to come to either one of the virtual classes this week, or hopefully the live class on Thursday, although it is getting very full. So that might not be an option very quickly here. All right, well, I hope that helped, and I will see you next week.